Okay, so, well, here are the Taylor expansions or the polynomials of some of the most common functions that we usually deal with. And you can try and derive some of them on your own, but so we've done this in the previous video with 1 plus x to the alpha, but then we can have all of this, right? So the logarithm of 1 plus x is x minus x squared over 2 plus x squared over 3 and so forth. E to the x is 1 plus x plus x squared divided by 2 factorial, so on, okay? You don't need to learn them, all of them, right, from memory, right? Well, a few of them are important, right? So for instance, e to the x is the sum from k equals 0 to n of x to the k divided by k factorial plus small o of x to the n, right? So this is a very basic one, right? And so for instance, the sign of x is just the sum from k equals 0 to n of minus 1 to the k times x to the 2k plus 1 divided by 2k plus 1 factorial plus small o of x 2k plus 2, right? And in this case, what you can see with the sign, you try computing it, is that derivatives, the odd derivatives are the even derivatives are 0, because you have the sine is 0, then the cosine is 1, then the sine is 0, then the cosine is 1, okay? All of these are at 0, approximately at 0, sorry, right? So then you have the first derivative, f at 0 is 0, right? And then the first derivative is 1, so you have plus x, and then the second derivative is 0, which is sine again. The third derivative is minus the cosine, so you have minus, and you have x cubed divided by 3 factorial, and so forth, okay? You have plus x to the 5 factorial, minus x to the 7 factorial, and so on, okay? And then the cosine is the same, but the other way around. You start with 1, and then the first derivative is 0, then we have minus the cosine, so you have minus 1 times x squared divided by 2, plus x to the 4th divided by 4 squared, and so forth, right? And so you can see from this, right? Well, yes, so the exponential, the sine, the cosine, and the logarithm are things, and maybe 1 plus x to the alpha, are things that you should know, okay? If not by memory, very close. The other ones, if it's useful that you learn the first terms, right? Especially for the tangent, or some of this. Otherwise, you can derive them pretty easily, right? You just need to derive these functions and evaluate at 0, right? Now, what I wanted to say, that from here you can see now all of these equivalences that we have been saying, right? So we have e to the x is 1 plus x plus blah blah blah, right? And we have always been saying, so this is small o of x, for instance, right? We have always been saying that e to the x minus 1 is approximately equivalent to x. Well, you have it here, right? E to the x minus 1 is x plus the small o of x. You get it here, right? Now it's the same with the logarithm. The logarithm of 1 plus x is x plus things that are small o of x. The sine is x plus things that are small o of x cubed. The cosine minus 1 is minus x squared over 2 plus things that are small o of x squared, and so on and so forth, okay? So you see all the asymptotic equivalences that we have been working with before arise naturally when you work with Taylor polynomials. And not only that, you can improve on them, right? You can say that the sine is approximately equivalent to x minus x cubed over 3 factorial, because sometimes in computing some limits, that extra factor is going to be needed, right?